So today I will tell a story that is how I became a data scientist. So this is more like I want to come clean in the sense that for some reason people assume that very often, not everybody, but very often people assume that I have some sort of like PhD degree in computer science or statistics. I want to assure you that's not the case. So as mentioned earlier, that I have a master's degree and a bachelor degree, but both in electrical engineering. But today I'm telling a story, in a sense, just to prove that I can talk about other things, something other than Kaggle. I have given, I'm sure you have seen, some of you have seen my Kaggle presentation about Kaggle competitions and GBM and so on and so forth, and I've heard complaints actually that I already talk about the same thing. So today I'm going to talk about something different. I promise you, this is not technical. There's nothing technical in today's talk. So you can leave now. I will not be offended if you have to. Today's goal, as always, is to entertain, not to enlighten. So don't take what you hear today too seriously. And I will explain why at the end you shouldn't take too seriously. There might be one thing that I think is really useful, but all the other things hopefully just make you laugh, I hope. And also for the purpose of today's presentation, I have to presume I'm an expert data scientist. I know that's not up to me, that's up to you guys to judge, but I have to assume that, so that it's an interesting story. So the story is how the cute baby become the guy on the right that's wearing glasses. That's what we call him Clark, that he represents expert data scientists. That's a little bit plug for the company I work for, DataRobot. We use him for a lot of marketing purposes. What I learned, okay, this is not data science, this is behavior science, is that if you keep showing people the same message, they will believe it, regardless of what it is. So I just keep telling this guy is a data scientist. Then a year later, you will think he's a data scientist. I actually apologize. I actually had Drew Conway's Venn diagram there. But after I heard so many people make fun of it yesterday, I've changed it. So it's not Venn diagram anymore, just 3 bullet points. So what it takes to be a good data scientist? And my slide doesn't have the word unicorn, because I heard complaint about those two. So I think that the common theme about the 3 legs of being a good data scientist or a competent data scientist, I think those are well acknowledged: domain knowledge, coding skills, and math and statistics. However, just from my own personal experience working in corporations as a data scientist, I think it's equally, even more important to be able to ask the right question and to tell a story. I think more and more as machines become more and more powerful and people write better and better software and do like what the new concept like automatic machine learning, just like self-driven cars. Eventually, I think we might get to the point we have, just like driverless cars, we have like data scientist-less data science. I don't know if that makes sense to you or not. But still, even driverless cars need human, because there needs to be a human to set the destination. The same thing with data science. So there always will be a need for us to identify the problem to solve. And so my view is that a good data scientist is the one that can connect the technical solution, like the decision tree on the left, to the real world. So basically, you can think that data plus model plus data scientist equals money. And that's how we sell ourselves to our employers and customers, our sponsors. So, if we really start from the baby, the baby picture, and think about what make a kid, a teenager, a toddler. I have kids, they are like kids, they are not 7-year-old, I don't know what they call them. Second graders. So, can you tell if this guy is going to be a good data scientist or not? Because it looks like a promising profession at this point. I do wish that my kids grow up and they make some money and give me some. So that's part of the retirement plan, right? So to be honest, that is the retirement plan, the investment. So I think the one relevant skill, technical skill that for children is math. How good are they with math? So personally, I was good with math, especially the quantitative kind of math, the quantitative kind of math, like arithmetics, estimations, averages. I was terrible with algebra. I struggle with all kinds of those those functions and function-based real analysis, those kind of things. And I had a very hard time proving theorems. You know, I could, but it's a very contrived process for myself. But in a way, I think that's why I like data science. You know, the data science is not like computer programming. It's not software engineering. In data science, the rough answer is actually good enough. As long as you can estimate something, there's always noise. You can always blame that on oh, there's noise in the data, and people say, oh, that's okay. Yeah, there's nothing we can do about it. Yeah. You know, I guess the world changes once you pass the present and look back in the past. In hindsight, you know, our destiny is always clear. So my destiny was to become data scientist. But when I went to college, there was no such thing as a data science as a major. Actually, my major was more like industrial engineering. I was majored in electrical engineering, but more specifically in control systems. So in case you are younger than like 55, so you never heard about control systems. So control system is basically the top right, there's a picture. You have an input, and there's some sort of system that's A, and then there's output. You take the output signal and do a feedback through B to get a desired output. A lot of times in your industrial system, the desired output might be you want to maintain the right temperature in the reaction chamber. So that if it's too high, you cool it down, it's too low, you warm it up. I spent 5 years studying those things. So what did I learn useful in college? You never know what is useful in college when you're in college. That's unfortunately the problem with education. You only know what's useful like 10 years after you've done that. So in retrospect, linear algebra is the most useful class I took in college, and unfortunately was also the one that I scored the second lowest. I had something that's even more challenging. So, but still it's useful. And you know, like everybody who was in engineering major, you learn some programming. And you know, I'm sure some of you have learned a language called Fortran. I learned the language Fortran, that's how I learned programming. It's actually a very good mathematical language. And the last thing that I think we all learn in college, and in my opinion is actually more important than all the technical thing we learn in college, is teamwork, how to work with other people, also how to play with other people, how to party with your friends. That's actually very important. I think that's why people go to college. You know, if there's no, so that's why I do not believe in those online education like Coursera and ODSC, those things. Yeah, they're cool, yeah, but you know, you can't party through Skype. Maybe you can. So after I studied college, and then went to University of Toronto and continued my master's degree there for a couple of years. And then like everybody, almost like all my classmates, you know, remember that I was in electrical engineering major. We studied control systems, those A, B, C feedback loop. But I think 90% of us found a job to program. You know, we have somehow become a programmer. And even after the .NET bubble burst, there was plenty of IT jobs. And I happened to find one, and I happened to find one in the insurance industry. So I think the insurance industry certainly has the reputation of being very backward and conservative and boring. But I think it's actually a fortunate thing for me, because the insurance industry, in my opinion, has one of the most interesting data to practice data science on. So insurance industry's data has a very large variety, and it's not too big. You know, if you have like billions and billions of records, then what you can do with it is actually very constrained. You probably linear or logistic regression, that's it. And it's not too small. You know, if you only have like 10 records, you know, what you can do is also limited, it's basically nothing. It has medium-sized data, have a high variety, and it has a lot of noise. So you can, you know, try all kinds of models and learn a lot of signal versus noise, how not to overfit, and lots of sort of things. So I found it is a good thing to work in insurance, but not for your whole life. Okay, you get in there, spend a few years, but get out. Before you're branded as the insurance guy, seriously, is a problem. So working in IT was fun actually. So writing programs and sitting there. It actually show the picture. Yeah, that's the guy sitting there. It's very comfortable chair. I learned a few things from IT, and it's definitely not how to program. I think my coding skills definitely became worse after working in IT because that's not really a big part of the work. The biggest thing I learned was really about insurance. So learning about the domain, knows all the coverages, all the claim handling processes, and those are really useful. And in many ways, that I can talk about the insurance in a reasonably competent way. Actually, it's more helpful for my career than my Kaggle achievement. So seriously. So when people ask you what you do and you can talk about the business, that's actually very important. And it's very important to speak the business language. I have worked in 4 different insurance companies, and the different insurance companies have their own terminology about the same thing, the similar insurance product. They have different names. Actually, it's very crucial that you get terminology right. And in a way that I feel is very important that we feel respect toward the business. Do not dismiss the business as a bunch of suits just having meetings every day. Both are true, but that does not make them less useful. The last thing I learned was more like a side effect, a beneficial side effect, was how to talk to IT people. So when I was in IT, I used to hate it too strongly. I used to complain about my business partners. They always change the requirement. If you work in IT, you know what I mean. It's like the story keeps changing. Today they want the button on this side, tomorrow they want on the other side, and the day after they move it back. So we certainly have our approach dealing with those people, and we always say, oh, that takes a long time. So we build in all those overhead. And once I got out of IT, I became the business partners on the other side of the table, and I started hating the IT guys. Because they always say everything takes forever, and then whenever we want them to do something slightly differently, they will say, "Oh, you guys are changing requirements again. How can we finish this?" I can't solve that problem. Other than we try to do quicker iterations. However, at least I know what they mean when they say, "Oh, they take 2 weeks." That's very useful knowledge. But eventually, it's both from lack of interest, but also from my lack of skills. I'm not really a good software engineer. They are real software engineers. I'm half kind of my amateur. I eventually got kind of bored doing IT job. So what do you do when you are bored with the job? A career switch. Career switch is very popular nowadays. I think there's some studies show that the current job market is very different. People don't really work in the same career for entire life anymore. Usually people would change their career a few times through the entire 30, 40 years of working life. So I definitely had done that, I would say once already. I plan to do it one more time at least before I retire. So I haven't figured out what next yet, but I will. So the career switch, being inexperienced, the IT job was my first job, and I tried to find a different job. So I do very silly things. So I did the equivalent of the following. So let's say Clark wants to be a chef. So he goes to interview with the chef. So he tells the interviewer, who is actually an expert chef, he said, I have never cooked before, but trust me, I cook really well. So the lesson learned is don't do that. It doesn't work. So you can't possibly convince people that you can do something well, but you have never done that before. And to attempt to do so is damaging your own credibility. I certainly damaged mine. The only thing I found that could convince people is, what you have done, use cases, stories. In that way, that I find that today's environment actually is much more conducive to those kinds of things, because there are lots of meetups, volunteer groups, or boot camps where you have an opportunity to do a real project, and that is really absolutely necessary to get into a new profession like data science. There's another way that is very helpful, was to have the right mentor or sponsor. You need to have people who have faith in you and who will give you a chance. That's actually very, very important, especially in business. Because whenever someone take on a new guy who is a career switcher, they are actually taking a chance, and we should be grateful. So I was fortunate that I eventually got someone who was like a sponsor to me to the career switch, and that's how I did it. And I took a slight detour as well. So it might sound funny that I almost became an actuary. Actuaries are those people who make up insurance premiums for either car insurance, home insurance, or health insurance. Why? Because actuaries were doing data science way before data science existed. And the actuaries were doing data science way before computers existed. So actuaries have been doing the data science in the 1930s at least. And they have created a lot of good things. For example, is the credibility theory. It's really useful. I have found that immensely helpful in my data science career. Also, another reason is that my wife is an actuary, so that you see, actuary jobs seem to be easy. So I want to do that too. And last but not least, I'm really good at taking exams. So if you want to be actuary, you have to pass all the exams, then you get paid and everything. So I said, that's easy, I like exams. Seriously, I'm really good at exams. Why not? So I was rescued in a way that by data science, and before I became a fully credentialed actuary, there was data science. And I found that data science jobs are more fun, they pay more, so I became a data scientist. So finally, I made it to data science about like 6-7 years ago, and so I went from this guy on the left to the guy on the right. Big difference. If you, I don't know if you can see it now. I actually put effort into making this picture. Because honestly, if you look from outside, that's exactly the same thing I do. I sit there working with a computer before, and I sit there working with a computer after. But what's on the screen is different. If you look at it really carefully with like either a telescope or get the slides, the left guy has C++ code on his screen. The right guy has ROC curve confusion matrix on his screen. I'm not kidding you. You get the slides, you zoom in, you will see it. And so soon after that, I became an expert data scientist. So how I become an expert data scientist? So we start. Actually, when I first got to work on data science, actually was called a predictive modeler, and it sounds way less cool than data scientist. That's why we are data scientists now. To a large degree, I was legitimized by Kaggle. So because it's actually very difficult to change people's impression of you once they know you. So first impression is very important. So for the people who actually saw me move from IT to doing predictive modeling, they always see me as the IT guy who wants to do modeling. I mean, that's just inevitable because they know me like a couple years before that. So the trick there is to find new colleagues. They do not know you IT past. So you come here, you know how to be modeled. You are the expert data scientist here. That's it. If one job switch is not enough, then do two. I promise you, you do not need to do 2 job switches to become expert data scientist. So I became a data scientist. I was a practitioner. I think I never understand the practitioner word. It's like the practice itself is noun, and make practitioner, that's also sound noun, and they add ER on it. But anyway, I think we want to find a word that sounds like researcher, but not researcher. That's a counterpart. I learned a lot at AIG. AIG Science was a fascinating environment. Just like every group that grow from 0 people to 120 people in 2 years, you see that growth period is a very good learning environment. So we used to joke that we should charge people to work here because it's so much fun and so much opportunity to learn. By the way, what I learned the most is that if you are talking about making a difference, asking the right question is always more important than finding the perfect answer. Despite we spend hundreds of hours working on Kaggle and create ridiculous ensembles of hundreds of models, in reality, if you have the right question and you have the right data, linear regression usually is good enough, or logistic regression if you're doing binary. Because what we need to do as data scientists is to put results to work and make changes. You want to ask the question, what will you or what can you do differently once you can predict something? You need to be able to answer that question really, really easily and clearly, find a direct connection between what you can predict to what you will do differently and to the business impact before you start a project. You can't answer that question, don't start a project. And that's very important. And that will help you, at least in my opinion, that help our career and also help data science as a profession. We don't want to be seen as people who like to tinker with their model forever. We want to be seen by business people, by the way, who pay our paychecks, as the people as the helper that make difference for them. So that's how I become data scientist. And here, but I don't want to finish here, because if we finish here, then we are just making. I would be making a mistake in data analysis, because we actually saw one data point. All we have is an anecdote. Is only become data science. It doesn't mean you shouldn't draw any conclusion. So I think if we look at this in this way, we all understand what is good, what is bad for data science. So we don't like anecdotal evidence. We want generalizable evidence. Co-occurrence doesn't mean anything. We actually need correlation. But even correlation may not be enough. Very often we need causality. So I want to finish this by showing a trivial example. Let's see that Owen was good at math and became a data scientist. Can you draw any conclusion from this? And if you want to draw any conclusion from this, then you're not qualified. You should find a different career. Don't do data science. That's not good. So because there's only one data point, but you can find, the world is so big. You can find anything if you want one data point. Let's say, suppose that 1,000 people were good at math and then became data scientists. Is that good enough? That's still not good enough, because the real question you want to know is what happened to the people who are not good at math? Are they more or less likely to become data scientists? It's actually possible to have this kind of weird setup. When you look at the contrast group, they're actually more likely to be data scientists. But this is made up, for example. So in reality, it's more likely to see this, that people who are good at math is much more likely to become data scientists. But before you do anything about it, certainly we find something. It's a meaningful correlation. It's probably very generalizable. But is this good enough for your use case? That highly depends on your use case. If your use case is that I want to hire a competent data scientist, then I think this is good enough. You probably want to ask some math questions so that they know that they can deal with numbers. But if you are a person who have loftier goals and you want to say that how can I change the world, we think data science is a good thing for the world. So we'll say we will start teaching kids more math so that they have a better chance of becoming good data scientists. That's not a given. So the data we just saw is not sufficient to support that approach. And with that, I will finish up and open the questions. And here's a plug for myself. I have an office hour at 1:30. So if you have questions that you don't want to ask in front of like so many people, you can ask me there. All right. That's it. Any questions from anyone? All right.
So I have a math background in linear algebra.
Yeah, yeah, that's good.
Okay. And I program. How do I start to put those two together? Like, how do I take knowing what function space is and applying that in Vista?
Yeah, the question is if I have a math background and I have linear algebra knowledge and then I can code, how do I put it together to become data scientist, right? That's the question. So obviously, as you know from the three electing, you need some business knowledge. So you have to choose a particular domain, just the one that you're more interested in or more familiar with, and get into it, and understand that, and find a problem that you can solve, you can help to solve with models. And then you are data scientist. Go ahead. Oh.
Who was your mentor or sponsor? You said you find a good mentor or good sponsor. Who was yours?
Oh yeah, actually he was. I don't want to mention his name because I didn't ask him for permission. But he was a chief actuary of that business unit I worked in. And so although I was actually from IT background, so I asked him that could I also work on some predictive modeling. He actually liked me. And then, but that's one step. But eventually he helped me. One more time, it was later he moved on to a different job. He got to work on a different company, still being the chief actuary, and he actually offered me a job there as a data scientist. I actually, to be honest, I didn't take that job, but I used that as an excuse to become data scientist at my current company. So that's how it worked. All right, yes. Yeah. Yeah. Okay, all right, I will repeat the question. So the question is, there are many people on Kaggle. On Kaggle, everybody have the same data, and everybody probably run the similar models. So what make like one person better than another? Let's get this out of the way first. So there's a fair amount of luck. So sometimes you can be really lucky, and sometimes I was really lucky, and sometimes I was really unlucky, you know. So most of my bad performance was bad luck, okay? So good performance is mostly my skill, you know, that's how I see the world. So there are at least three, you know, more technical differentiators. So one is effort. So Kaggle's system, I think, if you were in with Anthony's presentation before this, so it rewards points based on your activity, and you never lose points. So if you rank dead last in a competition, you still improve your ranking. So the more you participate, the better you will rank. The second one is there are different data set, different problems. Some people are better with one, some people are better with another. So me personally, I'm good at with problems that provide a context. So if you have multiple data sets and they are real, you know, column names in there, that's why I can think about what the data represents. I usually do better. Then you have one single table with all the features anonymized, like V1, V2, V3, V1000. Then I was like, yeah, I couldn't do anything. So because Kaggle's points rewards activity and has a time decay. So if it happens that there are consecutive competitions that, in my ballpark, you will see my rank goes up. If there are consecutive competitions that I hate, then my rank will go down. So the third is, it also has to have a faster computer for some competitions. And sometimes the data sets are not always small. Sometimes they have like gigabytes of data. So if you happen to have access to a bigger computer, or you can get some AWS accounts and stuff, it makes a difference because the time is limited.
I'm probably in the same position you are 7, 8 years ago, going through a midlife crisis. So
I'm doing that right now. Okay, so all right, go ahead. You do it, George. Yeah.
So I'm in the data field, but not very technical. I never taken linear algebra or programming classes. So I'm looking at data science, and I'm looking at our programs out there, massive programs. So what would you recommend to someone in my position who want to get to the field without having to spend the next 2 years and $60,000 or $70,000, $80,000 to get a massive degree? Is there another way?
Yeah, there is.
Without having to commit that time and money investment?
Yeah, it depends, right? So you can save money and you can save calendar time, but you can't save time. You have to spend like hundreds, maybe a couple thousand hours studying it. So it's your choice, either do it during daytime or nighttime and weekend time. So my personal opinion is that you don't have to go to a school to get a degree to do that. But you do need to get two things. One is you need to get to the point where that you know how to do it. So that's half of the question. The other half is how you have to convince other people that yes, you can do it. So the first half I think is easily handled nowadays by going through Coursera classes and do Kaggle competition. But the second one, you probably need to find some sort of way to, some sort of activity or opportunity to practice it. Actually, I feel that, okay, first, I'm not saying this for commercial purposes, but I think a lot of those boot camps, actually it's a reasonable opportunity. I don't think they can, okay, sorry, I mean no offense if you are associated with any data science boot camp. I don't think that you can learn data science in 6 weeks, 8 weeks, or 12 weeks. Okay, I don't think, maybe there are, if you can do that, you probably can learn it in a day, let's put that way. I don't like 12 weeks to learn data science, I mean, but however, they do give you an environment where they have more or less real world data set, and the project, and the deadline. So I think that is actually very helpful. So that gives you the best chance to be able to talk to future interviewers saying, I have done this problem, I have this data, that's how I approach it, that's how I solve it. I think that's probably the way that you spend like 1 year, 1.5 years going through Coursera classes, just in the evening do some Kaggle computation, get through the technical things, and then spend a few weeks doing a data camp, like boot camp thing. I think you're done. That's my opinion first. Another question? Oh, all right, the one in back.
So you talked about the importance of domain experience and domain knowledge. How transferable is that around? What's the best way to gain new domain experience and domain knowledge? I have to say that it's actually pretty hard. So that let me be honest with you, I think actually it's quite hard. Data science does not make domain knowledge more transferable. So data science knowledge is transferable, but domain knowledge is not. For example, I work at property and casualty insurance industry. So that means the car insurance, work compensation insurance, home insurance. But you would think health insurance is close enough. I have no idea how health insurance works. Or life insurance. It doesn't transfer at all. Oh, sorry, you have to start a new. Okay.
When you talk about, you talked earlier about knowing how to ask the right questions.
Yes.
That's really the domain side of it, isn't it? It's something you just can't intuitively know.
No, yes. You need to know the domain and you need to understand the business goals. So that, but it's more, in my opinion, it's more a mental discipline. Because we data scientists have a tendency to tinker. Sometimes we got data science, we got excited, we couldn't care less like what's the real world impact, but this is interesting. We have to resist that temptation and really think, is this useful? Yeah, that's how.
Well, I'm sorry to follow up on it, but so how do you succeed in all these different areas of Kaggle when you don't have the data or the domain knowledge? You must be asking the right questions.
Yes, because no, actually, Kaggle is different. In Kaggle, there's no such issue of asking the right question anymore, because Kaggle, by defining the target variable and data set, that is solved. But the domain knowledge still is important because that helps you to do feature engineering. So actually, because the Kaggle competition lasts like 2-3 months, right? That's enough to be like an amateur in a field. You read, sometimes I do read magazines, like trade magazines, just to understand the industry. Like for example, there was a Expedia sponsored like a web hotel ranking competition. You definitely want to go look at the travel industry and go to Expedia sites a few times. That's immensely helpful. All right, any other question? We may be running out of time. Yes, we are running out of time, guys. Thank you.